Hey guys, welcome to class today, and thank you for joining us in our 4-part series on biological form and function. Each of the classes coming up in the next 4 weeks will cover a different aspect of form and function. And today's class, we're going to talk a little bit about anatomical form and function. My name is Wendy Martin, and I will be your teacher and your guide through these next 4 sessions. Now, what I would like to do is just really quickly touch base on the objectives I hope to meet in today's class. So I know that you guys are all seated at a lab session, but for now, why don't you come up a little bit closer and join me in the front. And since there's 4 of you, we'll each take turns looking at these different objectives. If you look at these sticky notes up above my T-Rex skeleton, the 4 objectives of today's class. And this is an activity and you just getting to pick them up, look at them, try to figure out where one bone attaches to another, because there are some very distinct points of attachment. You've got a little skeleton next to you that you can use as a reference. His name is Stan. He's our friend. And I will also keep this up for a minute so you can look at it too. So I'll give you a few minutes. You can unmute yourself while you're doing this if you want, so that you can talk to your partner, or you can just ask me questions as you're working. We'll walk around. So let's go ahead right now. I want everybody to find a lab station. Each lab station has a different animal. Find an animal that maybe you and I want you, and you can work with a partner if you want. And now, right now, the animal can't touch, but I'm going to go ahead and give you all one that you can also pick up and touch. I want you to take a couple of minutes, and if you want to work with a partner, go ahead. Take a couple minutes, look at your animal, and then think about where this animal lives. Think about how this animal lives, and see if you can come up with a couple of adaptations that make this animal kind of unique. All right, so here's a bigger elephant for you guys if you want to look at that one. Renee, what do you have? You've got the killer whale, the orca. Let's find you the orca. I'm just going to give you guys a couple minutes just to kind of play with the animal, look at your animal. Now look at the difference though, guys. Look at how the orca moves caudal tail versus how the shark moves his caudal tail. They move it to propel themselves. They definitely have that large fin that you see coming in water that can scare you. They have the larger fins. This is the major that we see with sickle cells. Sickle cells do not stack up of each other neatly like a normal red blood cell would do. And so if you kind of make this little jumbled hodgepodge mess, you can see that this big clump of sickled cells is not going to go through a blood vessel the way it should. It causes a lot of clotting. In addition, these jagged edges, they hurt. People who have sickle cell anemia are in chronic pain. On top of that, these sickled cells right here don't last as long as a normal red blood cell should move around your body for about 3 months.